Assalamu alaikum. Thank you for giving me the opportunity to present here. Today I will be presenting our project on stock market price prediction using machine learning. This project aims to leverage various machine learning algorithms to predict stock price and assess their performance given their inherent volatility and complexity of financial markets. Accurate predictions can be immensely beneficial for investors and financial analysts. Let's dive into the details. So let's give a project overview about this project. So in this project, we utilize five different regression models: decision tree regressor, linear regression, boost regressor, gradient boosting regressor, and random forest regressor. So we will evaluate these models using a data set containing several years of daily stock data, including key financial indicators. The goal is to determine which model offers the best prediction accuracy. So, okay, we can see here we just mount our my drive from which I'm taking my data. So here I'm unzipping my data set, which is which I took which I collected from it was Z data and S&P 500 dataset. So here you can see there are many datasets, and we'll be working with this dataset. Okay, so okay, going down. Okay, so here you can see we begin actually by importing the necessary libraries. Pandas and NumPy are used for data manipulation and analysis. So that's why we imported Pandas and NumPy as PD and NP respectively, and also matplotlib.pyplot as PLT. So here I took a random data set, which I can say BX data set. So to read this data set, I just used pd.read is CSV, and I just stored it in df variable, and then I just use the .head function in df variable to show the first few datas. So here it's showing only five datas from first, as we haven't put any value. If we write 10 here and run it, so here it will show 10 values. Okay, so here going down. Okay, so here we can see the open graph, which is 70 the highest, which has frequency 200. And then we showed the tail data 10, like the value from last 10 values will be displayed here. And then, okay, you can see. So then we use the .info function to show the data type the of the elements, like date as an we will show data type the date as an object, open as float, high as float, low also as float, and close also as float, but volume as integer, and finally name as an object. Okay, so here we use describe variable to describe the data into many. Okay, so to describe the data into count, mean, standard deviation, mean, minimum, 25%, 50%, 75%, and maximum. So here we used open, high, low, close volume. So here count for open, high, low, close volume is all 1259.00. So mean, here we can see the values, standard deviation, minimum. So here the minimum and maximum we have seen. So here we can see different values for open, height, low, and close, and volume. Okay, so going next, uh, we use dot shape to see the total number of rows and columns. So we used 7 columns and rows, which is data of 1259. So here we use opening price graph. You can see the graph in opening price, and then and then we use the high price of data, and we labeled it as Apple, and days high price, Y label as high price, and X label as days, and plot as high. So you can see the high graph here, and then did the similar thing for low. Here you can see the low graph, and similar thing for the closing one. The graph is here, we can see. And then after all this, we took a new variable df2, and we just stored the close of df here, and just showed the tail value, which is tail. We used tail function to display the to show the last few elements, like five values to display. So here we use data frame, and then after using data frame, we use tail to show the last values. So here we would take future days equal to 100 to predict the values of 100 days in future. So here we just used, okay, tail, and we're just seeing the last few values, last five values here. Okay, so here we can see it has okay. So after that, the mod it we will be training our model, and we'll do some data visualization. Okay, so from is from is from sklearn matrix, sklearn matrix, we import mean absolute error, mean squared error. It is very important to know our prediction, as the prediction is good or not. As a we can measure the prediction by the mean absolute error and mean squared error. So the lowest the mean absolute error and the mean squared error, the the better the prediction would be. Okay, so so we imported library numpy. Okay, and then we are using from sklearn. Okay, so yes, from sklearn.model selection, we imported train, test, split to split the dataset into train and test data individually. So we took x train, x test, y train, y test, and split into test size equal to 0.2. So here we took future values, and then we will be importing gradient boosting classifier, and then we would use also random forest classifier, and then we'll be moving to the model one, which will be importing decision tree regressor. Okay, so decision so from sk.learn sorry sklearn.tree, we imported decision tree regressor. We would use this as a model, and then we would use the mean absolute error for test and prediction, mean squared error for test prediction, and then we just print the value of mean absolute error, mean squared error, and root mean squared error. So we found 6, 131, and 11 for mean absolute error, mean squared error, and root mean squared error respectively. So you can see the value is much less, so we can see the prediction is quite good. So here we can see the future 100 days of data here. So we can see we have plotted the uh, visualization graph, which we label title the model, titled as model, x level as days, y level as close price, and last of all we would go just normally. So okay, so here we can see the visualization. Here in the last we can see the green and the orange. So the orange one is actually the actual one, and the green one is the predicted one. So here it is the green and the orange line are merged so perfectly we can barely see the orange line, so which we can say by the visualization graph that it has predicted very well. So next yes, most important and another important thing to say is we took 1200 days of data and 70 up to $70 USD closing price. So we used linear regression as model 2, which we imported, and then we applied mean absolute error, mean squared error on test and predict test data for prediction, and then we printed mean absolute error, mean squared error, and root mean squared error. So we can see it is 6, 105, 10, which is less. So yes, we can say it is good, but in previous model we can see it was 131, 6, 131, 11, and here we can see in linear regression we can see 6, 105, 18, which is quite better because it has lower value than the previous one, and we're showing the 100 days of future values, and then we're plotting the data. We can see the the orange and the green line is parallelly growing indifferent to each other. So but it is predicting quite close. So okay, so we are going to next model, model number 3. We imported adaboost regressor. We would use adaboost regressor here. So as always, as previous one, we did the same things and we got the value 6, 86, 9, which is quite better than the previous one. We saw the mean squared error 131 and 100 100, okay, 105 for linear regression, but here in adaboost regressor we found mean squared error as 86, which is quite lesser than the previous one, and the 6 as absolute error, which is equal, but 9 as a root mean squared error, which is less than the previous. So you can see it is predicting quite good. So we can see the 100 future days, and then we're plotting the data. Here we can see the valid as going normally, but the prediction is just a single line just going straight parallelly. So it is quite not actually that good, but we can take this value normally. So then we're going to level sorry, model 4. We are using gradient boosting regressor. We're using gradient boosting regressor here, and we did the same work like before, and we can see it's 5 for mean absolute error, 89 point something for mean squared error, and 9 point something for root mean squared error, which is quite lesser than the previous ones. Okay, so so here we are showing the future 100 days of data. So okay, so here we can see the visualization, the orange one and the green one merging with each other quite goodly. So you can see the prediction is quite good. So last model 5 we used okay, so we are using random forest regressor. We imported it, and as like previous one, we are applying the mean absolute error value, mean squared error value, and root mean squared error value. We got 5, 106, and 10 for mean absolute error, mean squared error, and root mean squared error respectively, which is quite good, but not the best. Okay, but we are showing the 100 future days of value. So plotting, yes, we can see the valid and the prediction line is merging with each other quite good, and we can barely see the orange line, but here in green the last it just got down, which is got down, and which may be a different value. So here is our project overall, you can see. So okay, so this includes our presentation on stock market price prediction using machine learning. I hope this project has provided value insights into the potential of machine learning in financial forecasting. Thank you. So thank you for attention. I'm now happy to take any question that you may have. So this is my final. This is my final ending on, and I gave the presentation on the topic on my project stock market price prediction using machine learning. Thank you so much.